Okay, welcome to Algebra 1, Semester 2, Unit 6, Study Guide. As you notice, I think that I said this in class a couple different times, but if you haven't been there, you might not have realized this. All of the vocab that are put in the study guide are put in order so that you're not trying to look them up and find the answers. You're simply studying what the meaning is. You have an option. You can do it audibly. You can do it flashcards. There's a lot of different methods. Google different ways to memorize vocab and you'll find some ideas. Try and figure out how your brain works and what the best way is between now and finals. This is, again, Algebra 1, Semester 2, Unit 6 Study Guide. So, if we go down to the two problems at the bottom of page 1, are 6x minus 4 equal to 10 and x equals 3 equivalent equations? Well, in order for them to be equivalent, then 3 needs to be the value of the x in that equation. So if we take 6 times 3 minus 4, it needs to equal 10 in order for them to be equivalent. Therefore, we go ahead and multiply it. 18 minus 4, that would equal 14. 14 is not equal to 10. So, no, the value of x is not the same. So, they are not equivalent equations. Okay. Very bottom problem on page 1. We've got check whether the given number is a solution to the equation or inequality. I'm simply asking you to take that number that I put after the semicolon and plug it in for the x and see if it comes out true. 5 minus 6 equals negative 3. 5 minus 6 is negative 1. And that is not equal to negative 3. Therefore, no, it is not a solution. On this one, 45 plugged in for x plus 3 divided by 4 is greater than or equal to 12. 45 plus 3 is 48. 48 divided by 4 happens to be 12. And 12 is equal, and it says that it can be equal. So yes, that is a solution. Okay. Page 2 of the study guide. The very top problem. Number 4, 3x plus 4 equals negative 20. Draw a line down, subtract 4 from each side. This cancels. 3x minus 24 divided by 3. X equals negative, 6 times 4 is 24. 8 times 3 is 24, so it's negative 8. To check that, 3 times negative 8 plus 4 equals negative 20. 3 times negative 8 is negative 24. Plus 4 equals negative 20. When we have opposite signs, we subtract them and give it the sign of the larger. So negative 24 minus 4 would be 20. Sign of the larger would be that negative 20. Negative 20. So we do have it correct there. Next problem. Draw the line down. You're solving up the PIMDAs again, remember? Circle your creepy dude. What's being added or subtracted? That 2, so you subtract it. Cancels, we get negative 9x equals 36 divided by negative 9. X equals negative 4. Now to check it, negative 9 times negative 4, plug it in for the x, plus 2 equals 38. Negative 9 and negative 4 is positive 36, plus 2 equals 38. 38 equals 38, so it checks. Graph each equation. The number without the x value is your y-intercept, so you graph that first. You go up to positive 4, put the point. The number associated with the x, you turn into a fraction, 2 over 1. From that point, you rise to run 1. Now, if it's positive, you run to the right. Negative, you run to the left. This is positive. So we're going to rise 2. We're a little bit off the graph. Run 1 to the right because it's positive. And now when we go to draw that line, we know if we went up 2 and over 1 that we should also match going down 2 and back 1. So just make sure that your estimate was good. I always want you to count your slope or rise over run. Just run to the left if it's negative, right if it's positive. That eliminates all errors. Okay. Now on this one, to get y alone, we have to get rid of that 6x. In order to get rid of a positive 6x, we can subtract 6x from each side. But you'll notice you've got a number and a 6x. They aren't like terms. So we rewrite with the 6x written next to the 12. Okay. Now we divide by 3 on each side to get that y by itself. And we get y equals negative 2x plus 4. Now we graph that. Positive 4 is the y-intercept because it does not have an x associated with it. So we come up to positive 4. And we have a slope of negative 2 over 1. So we rise 2 and run 1 to the left. Again, it should match up down below. And we're pretty good. Now, I wanted to show you, when you look at these, you should double check your slope always and double check your y-intercept. You notice here we have a positive 4 y-intercept and a negative 2 over 1. So a negative slope should go up to the left, and it does, and it passes through positive 4. We go to the other graph, we do the same thing. Always check them when you're all done, because sometimes there's just little errors. Here we have a positive slope, up 2 and over 1. It does rise 2 and goes 1 to the right, so the slope's correct. Our y-intercept should be at negative 4. We graphed it at positive 4. So we need to erase that and move it down to negative 4. It's still up 2 over 1. So we now move that line down to where it should be. It's always good to go back and double check your graphs. Doesn't take much to relocate them if it's a simple error like that. Okay, bottom of page 2, we're solving absolute values. We have to get everything out from around the closet doors before we can open those closet doors. So we ignore what's inside. We say 2 is being multiplied by the closet doors, or the absolute value. We divide by 2 on each side. Now we get absolute value is equal to 4. Well, remember, an absolute value is the distance from 0. So if we're saying this could be 4 units from 0, it could be positive 4, or it could be negative 4. Or if you like the story form, we say, you know, before we open the closet door on this creepy dude in there, we want to go look at the ways we could run. We could run to the right or to the left. Now we open the closet doors, or bring out our absolute value expression, and here we go. A common error is students will change that expression. Never change the expression. Leave it the same in each of these. It's only the answer option that changes. Now to get x alone, we're going to add 2, x equals 6. To get x alone, we add 2, x equals negative 2. Those are our two answers. Now we need to check them. If we plug 6 back in there, 2 times 6 minus 2, well, 6 minus 2, you do it inside the absolutes first. That's just like parentheses in order of operations. 6 minus 2 is 4. Absolute value of 4 is 4 times 2 is 8. So that one checks. Now we go to the other one. Negative 2 minus 2 is negative 4. Absolute value of negative 4 is positive 4 times 2 is 8. So that one checks as well. Always check these. Okay, next problem. We want to clear out that times by 3. We get x plus 8 absolute value equals 4. Now we write our two answer options. We have positive 4 and negative 4. X plus 8 comes down, bringing it out of the absolute values now. We want to subtract 8 from each side, and we get x equals negative 4. X equals, if we subtract 8 there, we have negative 12. We plug those back in. Negative 12 plus 8, that would be a negative 4. Absolute value of negative 4 is 4, so that one checks. We plug in negative 4 plus 8 would give a value of 4. Absolute value of 4 is 4, so that one checks. Okay, we're down to our last one. In order to get the absolute values alone, we subtract 6 from each side. We get absolute value 3x plus 2 equals 6. Now we need to give our two answer options. We have a positive 6 and a negative 6. Now we bring down what was inside the absolutes. 3x plus 2, 3x plus 2. And now we solve these equations. We're trying to get the x alone, so we subtract 2 from each side. We get 3x equals 4. Now we need to divide by 3 to get the x alone. So we get x equals 4/3. Here we have a negative 6. We're subtracting 2 from each side. So we get negative 8 equals 3x. So we subtract by 3 on each side. X equals negative 8/3. And so that checks. We can put them back in there to check them. 3 times negative 8/3 plus 2. The 3's would cancel. We'd get negative 8 plus 2. Negative 8 plus 2 is negative 6. Absolute value of negative 6 is 6. So it does check. Here we have absolute value of 3 times 4/3 plus 2. The 3's will cancel, and we have 4 plus 2, which is positive 6. Absolute value of positive 6 is 6. Okay, page 3. This is the word problem on page 3, and this is the tolerance problem. We had it in the notes as well at the end of this unit. Again, you're looking for the target. The target is 48 inches. Come right down to the graph and make sense out of the math. Please make sense out of the math. Put the target in the middle. And then look for the error. Absolute deviation is your error. It's 3 inches. You can fill it in here where it asks for the deviation. That's 3 inches. Now come down to your graph and think this through. If your target's 48, but you can be off by 3 inches that way, or you can be off by 3 inches that way, what is your minimum and maximum height? Well, your minimum would be 45. Your maximum would be 51. Just subtract 3 and add 3. So up here in the blank, your maximum height is 51 inches. Your minimum height is 45 inches. Okay. I do ask that you use the formula to show how you got that. So it's really going back to the math. Your absolute deviation was 3. Your tolerated measure is what you're solving for. Your preferred measure is 48 inches. So we have x minus 48 equals 3. It's time to open those doors. It's time to put your 2 options here. If it's 3 units from 0, it could be a positive 3 or a negative 3. Now we bring down our x minus 48. X minus 48. In order to get the x alone, we add 48 to each side. When we add 48 to negative 3, we get 45. When we add 48 to positive 3, we get 51. You don't have to check those because you've already made sense of it out of this graph here. Okay, in this problem on the test, I'm expecting you to plug in values into the absolute value expression and calculate. 0 minus 2 would be an absolute value of negative 2. Absolute value of negative 2 is positive 2. 1 minus 2, absolute value would be negative 1, and the absolute value of negative 1 is positive 1. 2 minus 2 is 0. No absolute value measurement because it's 0 units from 0. 3 minus 2 would be 1. Absolute value of 1 is 1. Sorry for the typo there. The absolute value of 4 minus 2 is 2. Absolute value of 2 is 2. So now print out your points. Make it nice and clear to me what you're graphing. 0, 2, 1, 1, 2, 0, 3, 1, and 4, 2. Now we come over to the graph. 0, 2 would be up here at 2. 1, 1. 2, 0 goes over and then not up at all. 3, 1 goes to 3 and up. And 4, 2 goes up like that. You know that an absolute value graph should be a V shape. You come out with a V shape, so that kind of double checks for you what it should be. Now, if you remember transformations from the unit, you can also look at this and realize, oh, that was inside the absolutes, so it will shift left or right, and it's always the opposite of how it looks, so it doesn't go negative, it goes positive. The last page, right over here, We're looking at transformations only. You should make sure that you've done all the notes and studied those videos. The first transformation we see is the negative. That means it reflects. I find students do the most accurate work on these if they go down and check all of them for the same thing. So the next one, does it reflect? No, because it's a positive. Last one, does it reflect? No, because it's a positive. Next thing that you look at is the slope change. Does it shrink or stretch? The answer is no, it's a 1 there. The answer is yes with this one. It's going to shrink by 1/2. We'll have a slope of 1/2, so shrinks 1/2. Now we go to the last one. It also shrinks by 1/4. Okay, now we're into the absolute value marks. Inside the absolute value marks is the shifting left to right, and it's opposite of how it looks. So we have a -2, that means it will shift right 2 units. The next one does not have any shift left to right. There's nothing in with the X. The last one has a shift to the left because it looks like a positive one, so it's going to shift left 1 unit. Go back up to the top. Our very last number outside the absolutes indicates shifting up or down. We see a +1, so we shift up 1. We see on the next one a +3, so we shift up 3. On the last one, we see that we shift down 2. So all of those have a vertical shift. Now we actually go over to the graph and we do what we say here. It's going to reflect, so it'll be graphed upside down. We go with the vertex of the parent graph, we move that vertex to the right 2 units and up 1, and we put the new point. And then we just reflect it upside down. The slope is not changed at all, so we draw it right through the diagonals of that point. Now we come over here and we answer what the vertex is. The vertex was right 2, so +2, up 1, 2, 1. You can also get that from right there. It's the opposite of what this one looks like, and that. That's your X value and your Y. In this one, we say the slope's going to change to 1/2 and it's going to go up 3. So our parent graph that sets like that is going to go up to 3. But now the slope's going to be rise 1, run 2. Rise 1, run 2. Okay. So we come over for the vertex. There's nothing in there with the X, so it would be 0. And it's up 3, so it would be +3. The very last one, we're going to go left 1 unit and down 2. So left 1, down 2, there's our vertex. It's going to shrink to 1/4, so it rises 1, runs 1, 2, 3, 4. Rises 1, runs 1, 2, 3, 4. Now we connect the line. And we connect the line here. That one I had to use a straight edge on. You should always use a straight edge, especially on my tests. Because I am looking to make sure that you've got some precision in your graphs. So you want to do everything you can to help yourself with that. Okay, so there's my graph real wide. The vertex would be -1, -2, because the X value is always the opposite of how it looks. Thank you very much. End of the video. End of that unit. Be ready for the test in class.